In this video, we're going to look further into the subatomic particles. Now, we know from our previous videos that atoms are made of the same thing: protons, neutrons, and electrons. And if you go and study physics further on, you can see that, well, these aren't the smallest things. We have gluons, we have quarks, so on and so forth. But for us in chemistry, we only care about protons, neutrons, and electrons. Now, if you look at the weight of these three subatomic particles, you can see that they're very small. Protons and neutrons have the same weight. Electrons are even smaller than that. But scientists don't want to look at numbers like these, so we say that a proton and a neutron, the weight of that is 1 atomic mass unit. That's what AMU is, or 1 Dalton. An electron is just a fraction of an AMU or a Dalton. Now, for matter is generally neutral. That is, the number of protons will equal the number of electrons. However, charge imbalances can happen, and in nature, what will happen is that matter will try to get rid of that excess charge. And we are actually all very familiar with that process. And one of the ways that this happens is through lightning. Now, what happens in lightning is that clouds build up a negative charge and the ground has a positive charge. And so the first step to lightning is that a channel forms from the cloud to the ground. And the flash that you see is actually the upward stroke of going from the ground to the cloud to try and balance out this charge. And you can see here in this picture is taken just milliseconds before a strike happens. And in this picture down here, you can see that the visible channel has already formed. That's why you see her hair sticking up. Now, if you're ever outside and it's very cloudy and you think a storm's going to happen and your hair starts to stick up like this, I would advise you to run. Now, we know everything is made up of the same subatomic particles, but what makes atoms different? Why is gold a metal while helium is a gas at room temperature? And the only difference is the number of subatomic particles that these atoms have. Specifically, the big difference is the number of protons. Now, the number of protons that an element has, we call that the atomic number, or you can also call it as Z. Now, this picture just shows you the size of a nucleus to an atom. So imagine that with this pencil, you make a point, and the atom is a whole balloon, and it's also showing you the difference in the elements. One, carbon's made out of 6 protons, you get a pencil. Helium made out of 2 protons, you get a gas. Now, for periodic tables, we arrange our elements from the smallest number of protons, or Z number, to the biggest number of protons, or Z number. So when you're looking at a periodic table, you usually have the chemical symbol and the Z number, or number of protons, right above it. Now, for this class, you will always be given a periodic table to work with on tests, so there's no need to memorize it, but you need to be able to read a periodic table. Now, all atoms of a given element will have the same number of protons. If they didn't, they would be different elements. However, the atoms of the same element do not have to contain the same number of neutrons. So, just as an example, 99% of all the carbon in the world has 6 neutrons, but 1% of carbon in the world has 7 neutrons. And we call these two different types of carbon, or any two different types of elements that have the same number of protons but different number of neutrons, they are called isotopes. And those of you who are interested, the chemistry club here on campus are actually called the isotopes, and that is why. It's elements with the same number of protons, but different number of neutrons. And neutron amounts in the wild are more or less consistent. So for example, if you have a sample of neon, 90.48% of your neon will always have 10 neutrons, 0.27% will always have 11 neutrons, and 9.25% will have 12 neutrons. It doesn't matter where you take this sample from, you will always find those ratios, more or less. And those percentages, we call those the natural abundance. That is, in nature, how often does this occur? And each element has its own natural abundances. And we can show this by using this terminology. So when we write out atoms, what we're going to have is we're going to have the chemical symbol here, X. So think of like Na for sodium or F for fluorine. Right above it, to the left, we're going to have its mass number. The mass number is simply the number of protons plus neutrons. And right below that mass number, we're going to have the atomic number, or simply the number of protons. And so to find out the number of neutrons, you just take your mass number, you subtract it from your atomic number. Another common way to do this is to have your chemical symbol dash and then the mass number. So here you can see that we aren't showing the atomic number, and that is because the atomic numbers is actually given by the chemical symbol. Neon always has the same amount of protons, so you actually don't have to list the atomic number in that case. If you give somebody the symbol, you have given them the amount of protons in that sample. Last thing we're going to talk about in this video are ions. So ions are similar to isotopes, and here ions have the same number of protons and neutrons, but what is different is the number of electrons. If an atom is positive, that is, it has more protons than electrons, it has a positive charge, and it's called a cation. If an atom has more electrons than protons, it has a negative charge, and it's called an anion. The way to remember this is cations are positive. Cat, pause, cat, pause. You get it? Yeah, I thought you did. And anions, they're, well, a negative ion. Anion. And we can write it like this. So we have lithium, and you can see since we don't have a number in the top right, that means that this number is 0 or lithium is neutral. Now, if lithium was going to become a positive ion, it has to lose 1 electron. So that's what's being shown here in this equation. Lithium, neutral, goes to positive lithium by losing 1 electron. On the other side, we have fluorine, neutral, and it gains 1 electron to go to negative fluorine. And ions of different charges have quite different properties than their neutral counterparts. They can and they cannot. It just really depends on the type of element we're talking about. All right, that's it for this video. See you in the next.